Good afternoon, everyone. Welcome to the annual Public Wetland Workshop for the San Onofre Nuclear Generating Station Mitigation Monitoring Program. Today, we are presenting the results from the 2025 performance monitoring of the Wetland Restoration Project. I'm going to walk you through the agenda before we start today. So I'm Kat Beshi, if I didn't already say that, and I'm one of the 4 principal investigators that lead the mitigation monitoring program. I'm going to begin with an introduction and overview, and then we will jump right into the performance evaluation of the absolute standards. And then Dr. Rachel Smith will come up to the podium to present on the results for the relative standards. And then we're going to open up the floor to any questions or comments. And so this workshop is designed to be interactive. We are here to facilitate a dialogue between our program and our audience, both in person and remote on Zoom. So we will stay for as long as is necessary for everyone's comments and questions to be answered and heard. Okay? So please hold your questions till the end. All right, so before we jump into the specifics of the Wetland Restoration Project, it's useful to go through the purpose and rationale beyond the restoration itself. So the San Onofre Nuclear Generating Station, or SONGS, is located in San Clemente, California, just north of us here today. And units 2 and 3 are shown in the photo on the right. The SONGS reactors had a single pass seawater system that cooled the reactors. Units 2 and 3 had separate intake lines located in about 30 feet of water offshore of the power plant. And when operational, the power plant brought in water that was then elevated about 19 degrees Fahrenheit above ambient and then discharged through a complex diffuser system that was designed to dissipate the heat. Power plant heated cooling water in combination with turbulence was found to kill fish eggs, larvae, and small immature fishes. And these losses were projected to cause a substantial reduction in nearshore adult fish populations within the Southern California Bight. And so the California Coastal Commission considered construction of units 2 and 3 consistent with the Coastal Act only if these adverse impacts to fishes were compensated. The California Coastal Act requires any adverse impacts to the marine environment be mitigated, and enforcement of the Coastal Act resides with the California Coastal Commission. And as mitigation for those in-plant fish losses, the California Coastal Commission required Southern California Edison to create or substantially restore a minimum of 150 acres of tidal wetland habitat and provide funding for scientific oversight and monitoring that was independent of Southern California Edison. Another requirement was that this project accrue a total of 32 years of mitigation credit, which is equivalent to the operational life of SONGS units 2 and 3. So San Dieguito Lagoon was the site chosen for those out-of-kind compensation for those in-plant fish losses. And you can see the photo on the left shows pre-restoration what San Dieguito Lagoon looked like. There's an old World War II airfield, rural upland, and old agricultural fields. And over 2.2 million cubic yards of material were excavated and the area regraded to create the tidal wetland habitats that you see on the photo on the right. And outlined in white is the San Dieguito Wetlands Restoration Project area, which is the SONGS project. And I'm going to orient you now to some of the labeling that we use, because that'll be helpful when walking through this. So before we walk through the timeline, focus on the map in the top right corner. So west of the I-5, we have along the San Dieguito River Channel, the module W23, and immediately south of that is W1, which includes the large subtidal basin. On the eastern side of the I-5, to the north, we have W416. And then south of that, we have W510, which, similar to W23, lies along the main San Dieguito River Channel. Okay, so now I'm going to walk through the timeline. So we have color-coded the main management activities with blue indicating inlet dredging and gold indicating planting. So construction began in 2006 and was completed in 2011, but majority of the construction was completed by 2008. In 2011, that module W23 on the west side of the highway, tidal creeks were constructed in there. And that same module was later regraded to a lower elevation in 2014. Initial inlet dredging occurred in September of 2011 and has continued on a schedule of approximately every 2 to 3 years. And that's to maintain tidal exchange, which is a requirement of the permit. Now, planting early on in the project was focused largely on low marsh plant establishment of plants like cordgrass or spartina. Since 2011, a lot of that planting program has expanded and includes a diverse assemblage of species, and most of the planting has been focused on vegetating the mid to high marsh, and that is a planting program that is run by Southern California Edison with help from AECOM. And performance monitoring began soon after that initial inlet dredging in 2011 in September of 2012 and continues today. And this past year was our 14th year of monitoring. And so that's what today's talk is focused on, is 2025 or the 14th year. So physical and biological standards were established to evaluate the performance of the restored wetland and ensure that the restoration was functioning comparably to natural wetlands in the region. And there are two types of standards. There are absolute performance standards, which are only evaluated at the restored wetland. And to earn mitigation credit, all absolute standards must be met. And these sets of standards are evaluated based off of the current year. Now, alternatively, we have relative standards. These are sampled at the restored and reference wetlands. And for the wetland to receive mitigation credit, San Dieguito must meet a proportion of relative standards that is equal to or exceeds that of the lowest performing reference wetland. And these standards are evaluated based off of a running average. And Rachel's talk is going to go into more detail on the relative standards, but I do want to provide a bit of an overview about how reference sites were selected and recent changes to the reference sites as it relates to our assessments. So reference wetland selection was based off of criteria in the SONGS permit, which included that the reference wetlands be tidal, relatively undisturbed, and located within the Southern California Bight. And of the 46 sites that were evaluated or assessed, the 3 that you see here, shown as the circles, were chosen as having best met those criteria. From north to south, those are Carpinteria Salt Marsh, Magoo Lagoon, and Tijuana River Estuary. Spoiler. Okay, and so unfortunately, in 2024, Tijuana Estuary was no longer considered an appropriate reference site due to the influence of anthropogenic sewage flows. And so Los Penasquitos Lagoon was identified as best meeting the criteria for a replacement reference wetland due to its condition, its status as maintaining an open inlet, and the added advantage of it being in close proximity to San Dieguito wetlands. And so 1 year of mitigation credit is given for each year that San Dieguito meets all of the absolute standards and in a proportion of relative standards that's equal to or exceeds that of the lowest performing reference wetland. And the SONGS permit, like I said, it requires, and so fulfillment of the mitigation requirement is met when this project has accrued 32 years of mitigation credit. And the SONGS permit requires Edison to fund this independent monitoring, which is led by the scientists at UCSB and with advice from our science advisory panel. And this monitoring also tracks how the ecosystem is developing and identifies adaptive management opportunities pertaining to the physical and biological functioning of the wetland. Here we list on the left our scientific staff that without whom none of the work we're presenting on today would be possible. And we have just color-coded them to indicate whether they are located on campus at UC Santa Barbara or at our satellite office in Carlsbad. And then we also have listed here on the right our science advisory panel, which includes Drs. Rich Ambrose, Pete Ramundi, and Rush Schmidt. The monitoring program is led by 4 principal investigators, all of whom are here today to answer any questions you may have at the end of today's talk. And with that, I would like to certainly last but not least, I'd like to thank Dr. Mark Page, who will be retiring from the project this June and will be dearly missed. Mark has led a legendary career of doing really meaningful science that has had direct implications in how California's coastal resources are managed. And I just want to thank you, Mark, for your mentorship over the last 4 years and the tremendous contributions you've made to the project. All right. Okay, so now we're going to pivot to the performance evaluation for the absolute performance standards. All right, so like I said on the earlier slide, absolute standards are only sampled at the restored wetland, and all absolute standards must be met in order for the site to receive mitigation credit in any given year, and it's based off of the value for the current year. There are 5 absolute standards listed here, and we're going to walk through each of them individually. Okay. The first standard is the topography standard. This standard states that the wetland shall not undergo any major topographic degradation, such as excessive erosion or sedimentation. This standard has been met since monitoring began in 2012. Next, we have the plant reproductive success standard. This standard states that 7 common salt marsh plant species reproduce at least once in a 3-year period. And this standard has also been met since monitoring began, including this past year. Next, we have the exotic species standard. This standard states that important functions of the wetland shall not be impaired by exotic species that could have a negative impact on wetland functioning by, for example, altering food webs or changing the physical habitat structure. And this, too, is a standard that has been met since monitoring began in 2012. Moving now to the tidal prism standard. This is a standard that states that this tidal prism shall be maintained. The tidal prism is the volume of water exchanged in the estuary between a low and a high tide, and it's an important metric for tidal flushing, inlet stability, and inundation of marsh habitat. And we have actually changed our analysis for this particular standard, and so we're going to walk through that in more detail. I'm going to first begin by explaining how we survey tidal prism. So we survey the tidal prism at Jimmy Durante Bridge, which is about 1 kilometer from the inlet, and we tow an instrument called a river surveyor across the bridge. Each pass under the bridge is considered a transect, and these transects are spaced 15 minutes apart from one another. And it's an important thing to note that Jimmy Durante Bridge sits along the San Dieguito River channel, which drains San Dieguito Lagoon and all of its infills. San Dieguito Lagoon and all of its restoration projects. Oh yeah, sorry. Okay, so here we're showing a map of San Dieguito Lagoon similar to the slide you saw earlier, where we have pre-restoration on the left and then post-Songs restoration, which again was from 2006 to 2011. And more recently, another large-scale restoration was brought online, which is the Caltrans and Sandag restoration projects. So in 2024, over 70 new acres of tidal wetland habitat were added to the system, and these are areas that are outside of the Songs project area, and they're shown in blue in the map on the far right. And so one consequence of increasing the amount of tidal habitat you have is that you can expect the tidal prism to increase. And so in 2025, we surveyed our normal location, Jimmy Durante Bridge, but we also surveyed the inlets of these 2 Caltrans Sandag projects, W6, which is the triangle inlet, and then W19, which is the diamond. And like I said, it's important to note, so that circle represents Jimmy Durante Bridge, which drains and fills both the Songs and Caltrans projects. And so we needed to be able to account for the tidal prism of the 2 Caltrans projects, W6 and W19, so that our assessment of the tidal prism standard was restricted to just the Songs project area, or the area that we have been monitoring from 2012 to 2024. And so our initial analysis that we used from 2012 to 2024 was deemed insufficient at detecting the changes in prism from these additional projects. And so we developed a new analytical approach using the exact same survey source data that was sensitive enough to detect changes in prism due to these other projects and isolate the prism of the songs project area for our assessment of the standard, so that we can basically just know the contributions from songs. And so what we basically did was hang on, let me show you how this works. So the new analysis of tidal prism basically just takes the amount of wetlands submerged as a function of tidal elevation. That's like the new metric. And so what we do is, for each of those transects that I was explaining earlier, we take the change in volume and the change in elevation between two consecutive transects, and we divide them by one another to produce a new metric, which is wetland acres filled. And so we conducted these surveys at each of these areas, these 3 locations, and then we were able to subtract out the contributions from the Caltrans and Sandak projects to produce a value that would only represent the area that we've surveyed from 2012 to 2024. And so when we do that, we see that the tidal prism standard was met in 2024, as it is above the as-built threshold indicated by the dashed black line. And so, it was important that as proof of concept, we look and see how our results compared with this new analysis if we looked at our historical data. And so that's what we did. So we applied this same new analysis to our data from 2012 to 2024 to compare pass-fail outcomes, and they were comparable. And so that's good, because it means that these methods are compatible with one another. And so to reiterate, 2025 was the first year this new analysis was applied, and similar to years past, the standard was met. If you'd like to read more about this new analysis, it's a lot more detailed than what I've provided today. I encourage you all to scan the QR code, which will take you directly to our wetland monitoring plan. Oh, I can see everyone's grabbing their pens. All right. So now we will review the last standard, which is the habitat area standard. This standard states that the wetland habitat areas shall not vary by more than 10% from what is listed in the outlined in the final restoration plan. And the actual planned acres are listed on the right underneath the map that represents pictorially what that habitat mosaic looks like for the plan. And this standard was really designed to preserve the mix of habitats in the final restoration plan and guard against any unwanted large-scale conversion of one habitat to another, say vegetated marsh to mudflat or vice versa. And so this standard has yet to be met. And so we're going to dive a little bit more in detail on this particular standard. So one thing I should say is that the way that we analyze or assess this standard is we use aerial imagery that we assess in 10 by 10 meter grids. So the classification is done at the 10 by 10 meter scale using aerial imagery. And then I'm going to talk about how we classify each of the habitats next. So subtidal habitat is habitat that's below minus 0.9 feet NGVD and continuously submerged. Habitat is classified as mudflat if it is at or below 3.5 feet NGVD with less than 5% cover of vegetation. Salt marsh is habitat that's at or below 4.5 feet NGVD intertidal with at least 30% cover of vegetation, which again is assessed using the 10 by 10 meter grids based off of the aerial imagery analysis. And then there is a fourth unplanned habitat that was defined after monitoring began, and this is our other habitat. So other habitat, to put very simply, is habitat that's too high to be mudflat and too sparse to be salt marsh. And so this table here provides the planned acres, the plus or minus 10% of that acreage, and then the reported or calculated 2025 acres for each of the 4 habitat types. And you can see that subtidal and salt marsh habitat fell within that 10% range in 2025, but mudflat at 13.4 acres is 9 acres short of the minimum required, which is 22.4 acres. And so since the habitat area standard failed and the habitats and the absolute standard requirement requires all of these standards to be met in order to receive mitigation credit, this requirement was not met in 2025. If we look at the trend in habitat types over time. We see that salt marsh acreage has been increasing over time and exceeds or is at or around the planned acreage as of the last few years. Natural colonization by marsh plants in combination with Southern California Edison's planting program and a few really greatly timed rainfall years has contributed to this increase. In contrast, the area of mudflat habitat has been declining over time, and that's largely due to salt marsh encroachment into areas that were planned to support mudflat. And we are now 9 acres short, like I said, of that minimum required acreage. It does seem like possibly the rate of decline is slowing. So we'll dig into that a little bit more in future slides. Other habitat has been declining since 2012. There was a slight uptick in other in 2025, but there's around 12 acres of other habitat remaining at the wetland. And so one could ask, well, is there mudflat acreage to gain in areas that are currently classified as other? So again, you can recall from that table, mudflat habitat is between minus 0.9 feet NGVD and at or below 3.5 feet NGVD. And so if we isolate that elevation range and look at how the habitats, where the habitats are based off of these classifications in the 10 by 10 meter grids, you get a map that looks like the one on the right for 2025, where other is in gray, salt marsh is in green, and mudflat is in brown. And you can see that most of the other is surrounding mudflat area and or in the high marsh and likely converting to salt marsh. And that's represented really well in the figure you see on the right, which again is a time series of that same elevation zone of the entire project over time from 2012 to 2025 and looking at the proportional acres of these different habitat types. And you can see that mudflat has been declining, other has also been declining, and that is because salt marsh is growing. And so what this indicates is that there's really limited opportunities to gain mudflat acreage within the Songs project area. And that's due to salt marsh encroachment into areas planned to support mudflat and others conversion to salt marsh, not mudflat. And so a follow-up question could be, well, how much mudflat do we expect natural wetlands to support? And so we can use our time series of aerial imagery for the over 5 wetlands that we have historically monitored to, five monitors that we've historically monitored to try and address this question. And so here we're showing aerial imagery for the 4 currently monitored wetlands. The area monitored is outlined in black. That's the perimeter area. And then the 10 by 10 meter grids that are classified as mudflat are shown in brown. And you can see that the amount of mudflat really varies from site to site. Magoo has clearly the most mudflat of all the sites. And then places like Los Penasquitos maybe have the least. And so what we did was we basically took the classification data for all of these sites and we plotted them as the proportional area by habitat type. So the scale here is 0 to 1 to basically correct for area, right? If we plotted the raw acres, it would be harder to compare. So there's a couple of things to point out here. One is that the proportional area of each of the habitats is relatively stable at the references relative to San Dieguito. San Dieguito is more variable. The other thing to note is that the mudflat area at San Dieguito appears well within the range of what we see at the reference wetlands. There is a really important note here in that the Tijuana estuary classification is restricted to the northern arm of the estuary, which has less mudflat habitat than the southern arm. And so this is an underestimation of the amount of mudflat habitat at that particular site. But even still, it looks like the rate of decline of mudflat at San Dieguito may be slowing, and it appears that it's converging towards a proportional area that is more comparable to what we see at the reference wetlands. And so this upcoming year, we are going to try and explore the fate of the remaining mudflat habitat within San Dieguito more fully, which leads to our primary next step as it relates to the underperformance of the habitat area standard, which is to utilize a LiDAR digital elevation model that's funded by Southern California Edison to determine the area of planned mudflat habitat susceptible to future marsh encroachment. And the loss of mudflat habitat is part of this broader issue related to wetland performance and habitat conversion that Rachel will dig into more deeply in the next talk. And so with that, I'd like to bring up Dr. Rachel Smith to present on the results for the relative standards. Great.
So yeah, now I'm going to talk about the performance of the wetland related to the relative standards, which in addition to those absolute standards is what we use to assess wetland compliance. And so you've seen this before now, but as a reminder, the relative standards are measured at both the restored and reference wetlands. And in order to earn mitigation credit, the proportion of relative standards met at the restored wetland must equal or exceed the lowest performing reference wetland. And we evaluate the relative standards using a 4-year running average, which helps account for natural fluctuations over time. And so, as Kat mentioned in the introductory talk, in 2024, Los Penasquitos Lagoon replaced Tijuana Estuary as our third reference wetland that we use to measure the relative standards. And we started monitoring this lagoon in 2024, but 2025 was actually the first year that we were able to measure all of the relative standards at Los Penasquitos Lagoon. So that means that the relative standards actually vary in the number of years that we have data available. So some standards we have 1, 2, or 4 years of data available for depending on the standard. And so over time, we're going to be continuing to build out those averages so that we can get those 4-year running averages. And so to assess whether the restored wetland provides similar resources to reference wetlands, we measure 15 relative standards at both restored and reference wetlands. And so these standards include those related to water quality, to vegetation algal cover, to fish, invertebrate, and bird density and species richness, as well as food chain support to birds. And we also measure those fish and invertebrate density and richness in both main channel and tidal creek habitats. And so we measure both the restored and reference wetlands because the goal is for the restored wetlands to be similar to the reference wetlands. And so we determine similarity using a 2-step process. So first, we're assessing similarity at the standard level, which means, and in this case, similar means that the 4-year running average for a relative standard at San Dieguito equals or exceeds the lowest performing reference wetland. And so we assess this statistically using a series of t-tests. And we determine pass-fail outcomes for each standard relative to a confidence limit, which I'm going to go into more detail on the next slide. And then we combine these standard level pass-fail outcomes to assess similarity at the wetland level, where similarity means that the proportion of relative standards met at San Dieguito equals or exceeds the lowest performing reference wetland. And so for most of our relative standards, we determine pass-fail outcomes using a 1-sample, 1-tailed t-test that compares the mean value at San Dieguito wetlands to the lowest performing reference wetland. And then we apply that same approach to each of the reference wetlands to determine pass-fail outcomes for each wetland. And so for every t-test that we use to assess similarity, we calculated a confidence limit, which is shown here with this dashed line. And it really just represents the boundary between passing and failing. So this slide is meant to orient you to how we're going to be displaying the results moving forward. So for standards like vegetation cover, where higher values indicate better performance, values that are above that confidence limit indicate that a site is passed, whereas values below it indicate that a site has failed. But conversely, for standards like algal cover, where higher values indicate poorer performance, values that are above the confidence limit will indicate that a site has failed, whereas values below will indicate that a site has passed. So now, given that context of how we're going to be visualizing the results moving forward, we can actually dive into the results beginning with water quality. So we measure water quality with continuous water loggers, which are shown in these photos on the right. And we actually compare the mean sequential hours of hypoxia, which is when dissolved oxygen levels are below 3 parts per million. And so this is another example of one of those standards where higher values, I always get it backwards, where higher values are less desirable than lower values, as you can see by this arrow on the right. So anything below that dashed confidence interval or confidence limit line will indicate that a site has passed. And so in the following figures, we have all of these acronyms that represent the different sites. So SDW is San Dieguito Wetlands, LPL is Los Penasquitos Lagoon, CSM is Carpinteria Salt Marsh, and MUL is Magoo Lagoon. And so we're always going to be showing San Dieguito in brown and then the reference wetlands in light green. And then we're always going to put the site that San Dieguito is compared to statistically right next to it. So in this case, Los Penasquitos Lagoon, because it was the lowest performing wetland. And then these tables that we're going to be showing in the upper right-hand corner of these slides are just a historical log of the pass-fail outcomes for each standard at San Dieguito. So you can see that San Dieguito has consistently met the water quality standard, and this pattern continued in 2025, where San Dieguito and all of the reference wetlands also passed the standard. Now looking at the results for algal cover, the algal cover standard uses aerial imagery to assess the percent cover of algae. And so excessive algal cover can affect wetland function through impacts to vegetation, bird feeding, as well as water quality. And so this is another standard where higher values of algal cover are less desirable, as shown by that arrow on the left. And so this is another standard that San Dieguito has consistently met over the last 10 years. And this pattern continued in 2025 with San Dieguito passing the standard this year because algal cover was lower at San Dieguito than at the lowest performing reference wetland, which is Magoo Lagoon, which obviously had the highest cover of algae this year. So now moving on to vegetation cover. The vegetation cover standard uses aerial imagery to assess the percent cover of salt marsh that is greater than 30%. The standard has been on a positive trajectory. I think if you've been to these workshops before, every year we're like, this year it's going to pass, but this year it actually did pass. And so this was the first time that the standard was met. And this outcome is in part due to the success of Southern California Edison's planting program, with some nice plantings done coincident with good rainfall events over the last few years. And so now moving on to Spartina canopy architecture, this is a standard that is meant to assess the capacity for marsh cordgrass or Spartina foliosa, shown in this photo here, to provide habitat for ridgeways, rail, and other bird species. And we do this by measuring the proportion of Spartina stems that are greater than 3 feet tall. And this is another standard that San Dieguito has consistently met over the last 10 years. And this pattern again continued this year with San Dieguito passing this standard for 2025. Now moving on to the bird standards, beginning with bird density. So San Dieguito, from the schematic in the upper right-hand corner, you can see that bird density has been consistently met at San Dieguito, except for in 2019 and also this year in 2025. And so, however, you can see by looking at the mean value for San Dieguito, it is very close to that confidence limit. And so we can dig into a little bit more detail to better understand this underperformance by looking at the full annual time series. So just to orient you to this figure on the right, this is a time series of the annual values for bird density from 2012 to 2025. San Dieguito is shown by the upward facing brown triangle, and the reference sites are the other light green shapes. And so in this and in other future time series that we show, the separate highlighted values at the far right of the figure will show the years that are included in the average to assess compliance for 2025. So in this case, we only have 1 year of bird data for all of the wetlands, so only 2025 is highlighted. And so looking over the entire time series, you can see that bird density has been generally consistent at San Dieguito with a comparable density to Carpinteria salt marsh. But because of that replacement of Los Penasquitos Lagoon in 2024, we really only have this 1 year of bird data. So the variation is only associated with that year. And so given that bird density measured this year, that value is comparable to prior years and how close the value is to the confidence limit, we expect that as we continue to build out this 4 year running average, this variability will average out and the standard will again be met in future years. Now moving on to bird richness, this standard has been consistently met at San Dieguito over the last 10 years. And as in prior years, San Dieguito passed this standard and had the highest value for bird richness in 2025. Now moving on to food chain support to birds, this standard has chronically underperformed at San Dieguito relative to the reference wetlands since 2017. But again, with the replacement of Los Penasquitos Lagoon as a reference site in 2024, Los Penasquitos Lagoon was actually the lowest performing wetland this year and failed this standard, and San Dieguito did pass the standard. But as for bird density and bird richness, we only have 1 year of data for this standard, so it will be really interesting to see if this pattern is maintained over time as we continue to build out that average. Now moving on to standards that are measured in main channel habitats, beginning with fish density. So this is a standard that's been, intermittently met over time, and San Dieguito has passed this standard for the past few years. But in 2025, San Dieguito did fail the standard. And so again, to better understand this underperformance, we can look at the annual time series for fish density in main channel habitats. So you can see that fish density in main channel habitats has varied over time for San Dieguito wetlands, though it has been relatively comparable to the values measured at Magoo Lagoon. There has been a decline at San Dieguito in terms of fish density over the last 2 years. But again, we only have 2 years of data available for all wetlands to assess this standard. And so it is possible that as we continue to build out that 4-year running average, those fluctuations in fish density will average out, and it's possible this standard will be met in future years. And then similarly to fish density in main channel habitats, many of the same patterns here for fish richness. This is a standard that has been intermittently met, but that San Dieguito did fail in 2025. And if we look at the time series for this standard, we see that fish richness in main channels has also been relatively variable over time, often tracking Magoo Lagoon, but at many times lower than Magoo. Over the past 2 years, we have also seen a decline in the standard in main channel habitats. But again, we are only using 2 years of data for the running average for this year. And so we expect that as we continue to collect more data, some of this variability may average out in future years. Now moving on to invertebrate density and richness in main channel habitats. Invertebrate density in main channel habitats has been on a positive trajectory over the last few years, and San Dieguito wetlands met this standard in both 2024 and 2025. Invertebrate richness in main channel habitats has been consistently met at San Dieguito over time, including in 2025. Now we're going to move on to those standards that we measure in tidal creek habitats, beginning with fish density and richness. These are standards that have been intermittently met over time, and San Dieguito has passed these standards over the last few years. In 2025, San Dieguito did pass both fish standards in tidal creek habitats. All of the wetlands did pass the fish richness standard, and Los Penasquitos Lagoon failed the fish density standard in 2025. Now looking at invertebrate density and richness in tidal creek habitats. Invertebrate density in tidal creek habitats is a standard that's never been met at San Dieguito, and 2025 was no exception, failed this standard this year. Invertebrate richness is another standard that's been on a positive trajectory over the last few years. And so San Dieguito met this standard in 2025. Though you can see that the values for San Dieguito and Los Penasquitos were actually the same value for the running average this year. So no confidence limit was calculated and all of the wetlands passed. So now going into a little bit more detail about invertebrate density in tidal creek habitats to examine this underperformance. We see that the invertebrate density at San Dieguito has remained well below the reference sites since the beginning of monitoring. And in 2025, San Dieguito was still below the lowest performing reference site, which was Los Penasquitos. So it's a lot of data all at once. So to summarize, this plot shows the pass-fail outcomes for each of the relative standards for all 4 of the sites. And so you can see that Carpinteria Salt Marsh met all standards for that were assessed at that lagoon. Magoo Lagoon failed 2 standards, including algal cover and Spartina canopy architecture. Los Penasquitos Lagoon failed food chain support to birds and fish density in tidal creeks, where San Dieguito failed 4 standards, including bird density, fish density and richness in main channel habitats, and invertebrate density in tidal creek habitats. which makes it the lowest performing wetland this year. And so it did not pass the relative standards requirement for 2025. And then to sum up all of the results across both of the talks, as a reminder, to receive mitigation credit for a given year, the restoration project must meet all of the all of the absolute standards and also meet as many relative standards as the lowest performing reference wetland in order to meet the relative standards requirement. And so as Kat described, San Dieguito Wetlands has yet to meet the habitat area absolute standard due to the loss of mudflat. And in 2025, San Dieguito Wetlands also failed to meet the relative standards requirement. And so that means that San Dieguito Wetlands has yet to receive mitigation credit. And we're currently evaluating why the wetland is not meeting certain performance standards to inform potential remediation options if required. And so we've been working to understand the mechanisms of underperformance that are associated with both the habitat area standard and the relative standards requirement. And so as Kat had described in the previous talk, habitat conversion of mudflat to salt marsh has prevented San Dieguito from meeting the habitat area standard. And we see similar salt marsh encroachment into tidal creek habitats that has reduced sampling area and required shifts in our sampling location that impact how we assess the four relative standards that we measure in tidal creeks. And so in order to match the sample size of our reference sites, we aim to sample 6 constructed tidal creeks at San Dieguito Wetlands each year. However, due to salt marsh encroachment, in 2024 and 2025, it was only possible to measure 2 constructed tidal creeks, which are shown on the west side of the map here by those filled in circles. However, there's also been these 2 naturally formed creeks that have evolved to feed the frequently flooded mudflat on the eastern side of the restoration project, which are shown by those unfilled circles. And so in 2024 and 2025, we actually have been sampling those 2 naturally formed creeks and using them to assess compliance in order to more closely approximate the sample size of our reference sites. And so you can see from these photos on the right that the tidal creek geomorphology of these creeks is very different. So the constructed creeks that are experiencing salt marsh encroachment are much wider, shallower, and at a higher elevation compared to the naturally formed creeks, which are much deeper, narrower, and at a lower elevation, which also look much more similar to what we would see at a natural reference site. And so if we compare the outcomes for the fish and the relative standards that we measure in tidal creeks, you can see that most fish and invertebrate standards, except for fish density, are lower in the constructed creeks, which are shown in brown, relative to the naturally formed creeks, which are shown with the hatched marking. And then if we compare those results to what we see at the reference sites, we can see that the values collected in the naturally formed creeks are more similar to those that we collect at the references. And so by grouping the constructed and naturally formed creeks together when we were assessing compliance, that may mask some of the contributions of those constructed creeks, which were generally lower than the naturally formed creeks. And so given that superior performance of the naturally formed creeks relative to the constructed creeks, we're really interested in trying to learn more about the fate of those constructed creeks. We know that tidal creeks are an important feature of natural wetlands and that they were historically part of the San Dieguito Lagoon. And tidal creeks align with the song's permit objectives in terms of providing fish habitat. And obviously, we use them as a sampling location for assessing multiple standards. And so given these values, Southern California Edison is currently funding a modeling study to assess the optimal density, location, and geomorphology of tidal channels that can be supported within the SONGS project area, considering that broader hydrology of the entire San Dieguito Lagoon. And so that work will include a green LiDAR flight to develop a digital elevation model, like Kat mentioned in her talk, as well. And that will then feed into a hydrodynamic model that will help characterize the dynamics of tidal dynamics in creek channels and across the marsh plain. And then ultimately, the existing tidal creek geomorphology will then be related back to that hydrodynamic model with the goal of determining what creeks can be supported by the wetland restoration project. And so in 2026, we plan to review the modeling study and provide recommendations to the California Coastal Commission about the next steps for potential remediation or adaptive management at San Dieguito if needed, with the broader goal of improving wetland performance over time. So with that, I think we can move to the question/discussion part of the talk. And we're going to put these QR codes up here. If you want to find more ways to connect with our program, we have links to both our website and listserv. Our data is all publicly available, and we're always happy to chat about how to use that data. And then also follow our Instagram for more regular updates on project happenings. To answer your question. Yeah.
Any questions? I have a question. Are you guys planning on doing inlet maintenance this year?
Yes.
In the fall? Any questions from our remote folks?
Let's see. Oh, one just popped up on here. That's from Chris.
Yes.
It says for the LiDAR assessment of elevations relative to marsh versus mudflat, as well as modeling, would this include consideration of effects of sea level rise, where marsh would likely lose ground to mudflat at lower elevations?
Can you repeat the question?
Yeah, so I think the question from Jeff Crooks was for the DE. Hopefully I don't mess this up. For the DEM and modeling efforts, is this going to be incorporating sea level rise?
That's correct.
Okay. I think that's part of that data is ideally going to be thrown into a model where we'll be able to run multiple different scenarios, and at least one of those scenarios is going to be a sea level rise scenario, because we know how important it is to think about both the short term and the long term. And we know that sea level rise is definitely going to contribute to changes in the habitat distribution moving forward.
Good question, Jeff.
Yeah.
If sea level rise is considered, would you have to change the permits then to account for sea level rise?
So that's a Rachel question. But also, I think that the ORIP project has factored in sea level rise into how they approach similar standards. So maybe the SAP can also comment on that.
Yeah, so when the songs permit conditions were written, we didn't pay attention to sea level rise. And so we just weren't thinking about it then. And so none of the conditions say anything about it. And also in the planning, we didn't really look into it. So the mitigation project for the Carlsbad desal plant happened after. Has basically the same conditions word for word. But in the planning, we realized at that point, because it happened later, we realized that sea level rise was an issue. And so for that permit, in the planning, we said how many acres there would be at different levels of sea level rise. And so we are not there yet, but the expectation is as it's being evaluated, we will evaluate the areas as planned for the different levels of sea level. So we're not there yet, and Rachel can talk about that Coastal Commission, what they would actually do. But my thinking from a science advisor perspective is that we would adjust the acreage as if we had done it like at Harbor, right, where it was planned for sea level rise and how many acres we would have of each habitat.
Get more mudflat and sea level rise.
Yeah, so what that means is the acres that were planned would change with different amounts of sea level rise. And so that the comparison would be to what we would expect with that sea level rise. But it wasn't done in the original permit, and so it's not, and even in the Orbit permit, it's not, or the Carlsbad permit, it's not explicit in the permit conditions, but it was explicit in the planning and sort of from the very beginning.
And that's reflected in the monitoring plan for that.
Yeah, right. So it's so it was
not the permit, but
the in the plans we knew, we anticipated that this was going to be an issue. So the restoration plans looked at how many acres there would be at different amounts of sea level rise. So the monitoring plan, which is also not completed yet, but the idea is we accommodate. I don't know whether Rachel wants to.
I'm Rachel Powell with the Coastal Commission. Yep, we're really excited to see the results of the modeling study, look at the persistence of mudflat. I don't think there's any appetite from the coastal commission to take vegetation salt marsh and convert it to mudflat before we even have sea level rise occur. So right now, it's not something that we're looking to change the permit conditions for, but it's something we're definitely thinking about as we think about how to meet those habitat area standards, and we're gonna look reliably heavily at those happens.
Just curious, if they don't meet the condition, that's what happens to song, they have to keep going.
That's my understanding.
But it, you know, the permit anticipates that that might happen, so there's a remediation clause. So if the coast commission thinks there's something that Edison needs to do to remediate it, then that will be a requirement. And that's, and as Kat was talking about, I mean, that's what we're in the stage of seeing whether there is anything that we think should be done.
Yeah, and I want to point out that that's already come into play. So we're very excited that the vegetation standard was met this year, and that's because SE has been doing adaptive management with their planting program, putting that in. So we're excited to see that, and we feel like the trajectories are all on the right path. And so we're hoping it's modeling, point out mudflat persistence, those few things that we still haven't quite reached, but again, it's ongoing until they reach their credit. But we feel like we are using that adaptive management framework that was built into the permit to provide for remediation options.
So I guess in this case, sea level rise will be helping you, right? Because it'll start drowning out the plant and maybe more mudflat.
We're definitely in a much better position having more vegetated salt marsh than mudflat, for sure. Yeah.
That's a long way off.
Yeah, not to mention if they adjust your numbers up because of sea level rise, it won't help.
Yeah.
But it seems like you have a lot more birds at Magoo, where you have most of the mud flat, where you can actually see the birds. You can't see them in the marsh because they hide, and your survey is so short. You're just like, good chance you're not going to see the birds.
Mm-hmm. But that effort.
I don't do bird survey that way.
But that effort's consistent across.
Yeah,
you know,
but it's way easier to see birds in mud flat and subtitle than it is to see them in the vegetated marsh.
Definitely.
For sure, yeah.
For W19, do you guys do?
No, we do 3-hour quarterly bird surveys and total numbers and species.
Okay.
And we do the same amount. We still do TJ because it's got rails. We have rails requirement.
Got it.
So
you don't have plots. You just hunker down.
60 acres of salt marsh.
Yeah.
Survey.
Did you have another question?
I might have missed it. Why is San Diego?
Most of that site has been restored. So it had to be relatively undisturbed and not restored. That's also why a lot of the focus at Tijuana has been on that northern arm, because there's a lot of restoration work in the southern portion. Yeah.
And they looked initially at 46 sites. And so it's like a lot of trade-offs and trying to figure out which ones rise to the top. Yeah.
Are you gonna have an issue if they start the restoration of Penasquitos?
So we actually have looked into that, and Rachel, you've done most of that, but
I know it's going to be done in multiple phases, and I think that at least the first phase that's more likely to impact us is going to be in the higher reaches, in the like less tidal areas, and so if anything, we're expecting to improve the quality of the habitat. But
then it still gets being restored. So.
Yeah, but
not a vast amount in the first.
Yeah, it's not the tidal marsh areas that are being restored, which is what we're monitoring.
But we did look at that and talk to Mike Hastings and Jeff Crooks about that extensively before we solidified the plan for Los Penasquitos Lagoon. Yeah.
I have a question online from David K. He says in the years when main channel fish density and richness were depressed, were there any unusual changes in nearshore oceanographic conditions?
Oh, that's a great question.
Good question. Mark, since you were here during those changes?
But we haven't looked at that specifically.
Yeah.
But then that's why we have the reference sites too. I mean, take into account these changes that all wetlands may experience at the same time.
Yeah.
But it would be interesting looking at that across all sites.
Yeah, that's a good question.
I have another question here from Lori Coteen. Says, what are the possible activities that might follow the hydrodynamic modeling to improve outcome?
Who wants to take that?
Yeah.
Yeah, we're waiting to see what the results tell us. We're curious if we think tidal creeks are gonna persist, the ones that are naturally formed, if we think there will be more that are formed. Again, I think putting more heavy machinery out onto the marsh plain is not our most ideal option, and so we want to really understand what's going to be occurring with those natural dynamics that are happening out there and models into the future. So I don't have a great answer. We don't have a path, if this then this right now, but we're waiting to see kind of, is this system expected to have tidal creeks that do function even if they're not in the place we originally mapped them out to be in the original plan.
Are your naturally formed tidal creeks related to runoff from culverts? Do they form from discharge? Or are they formed from
I don't think so. Yeah, I think it's more like the
It looks
shape.
like they're very
Yeah.
incised.
But
Yeah,
I
they
feel
are,
like
yeah.
we've been seeing them deepen over time, and I think it's really more about the way the water is moving on and off of the mud flats, and it's like, creating a lot of scouring just from moving into that area. So, and I feel like that's what the hydromorphologists you're talking to at ESA were saying that they had expected this to happen given the way that the mud flat area was designed, and that often mud flat areas like we saw on those maps in Magoo, it's really like along the edges of channels, not like back tucked into the end of a creek. And so I think that when they looked at it, they were like, well, of course tidal creeks are forming there, and I don't think it's due to
That was the
discharge.
plan, actually. So what's happened is that it was much higher.
Yeah.
It's completely eroded out, and it was wider as well.
Yeah. And we've seen that same carving extending into the actual mudflat areas themselves, just because of how fast and the volume of the catchments is just so great.
Just touching in on the project. So I have been making observations over time, and the maps with the aerial extents, the restoration lagoon west of the freeways looks like it was blacked out. I mean, that was showing the lagoon, right? Or was that water?
West or east? Were you talking about? Did you say west of the freeway?
Yeah.
Like on this map, like where
It's blacked out.
That's water.
That's water.
it's water.
It's a big deep basin.
Yeah. Yeah.
That's a good thing.
Yeah.
Okay, so south of that is the,
W19.
Or you mean
no, the
the
next.
Fish and Game Basin?
The next basin was house fish and.
Right.
Time
Yes.
Game,
Fish and game. Yes. Yeah.
and that was in the 80s,
Mm-hmm.
and that was expected to help tidal prism.
Mm-hmm.
In your pictures, it looks like it's tidal nothing. Is that?
It's cut off. Actually.
Yeah. So it's cut off.
It's still connected, and it's still contributing to that prism.
And that's
Perch, so it's not really, because you didn't calculate in fishing.
That-
That bottom is the
Lagoon.
no, but that tidal area and whatever contribution it's made to the prism has been captured since 2012. So that has been part of the area that's been assessed since monitoring began in 2012. Yeah.
So if you go out there now, which I haven't,
Yeah.
are there fish in the Fish and Wildlife Lagoon?
Yeah, I mean, we actually don't survey in there anymore, but I think historically that yes, we used to do our training there. Yeah.
Cool.
Yeah.
Is there some fishing spot that's that?
Well, and because the Grandview overlook right there.
Yes.
That was
So
historic.
I'm really getting out of my range here, but 30 years ago, Joyce Edler, one of her concerns was restored wetland areas. The cordgrass appeared to her like it wouldn't grow to proper length to have the nests and the rails not float away to the ocean.
Yeah.
So I didn't even realize you guys are measuring cordgrass lengths. So did it start out that way, or did she change her hypothesis? She was just talking, so I don't know.
Well, that standard is based directly on that work and was designed because they knew that they needed it to be high enough for the bird nests. And so,
And you have rails in your site.
Yeah, we do.
yeah, which is very
Yeah,
cool.
they used to run through the parking lot. You have to, but so did the cordgrass start out like Joy was concerned and it just got taller, or has it always been okay?
It's always been okay, yeah.
Yeah.
Relative to Tijuana.
Yeah,
It always goes to the height, visually.
I'm an oceanographer, right?
There was a period where it took a while for it to actually get established, right? It was like a couple of years, but it was kind of not much happened basically, and then there was a scale insight that came early on. But most, it's been over 3 feet, you know, in historical. Obviously, yeah, it's done well,
Yeah.
and it's spread everywhere.
That's looking really good. Yes.
I was wondering about the marine protected area. Have you ever considered increasing that? I know the area that we know about is pretty small. And that would help control the fishing and perhaps increase the fish density. Might be right.
Well, so there's no take in like the Songs Project area. There's no fishing allowed in that portion. The fishing at San Dieguito is quite restricted. Shauna would be able to speak more directly to that.
Yeah, it's just east of the Grand Avenue Bridge where
Yeah.
they own property, fishing wildlife property.
Yeah.
That's the only place.
Yeah.
But so that's outside of your.
Yeah, that's outside of our area. So I think the legal fishing area is quite restricted already at the lagoon. Yeah.
And they can fish west of.
Yeah. But expanding an MPA is sadly outside the purview of our our responsibilities, but MPA expansion is always good. Anything remote?
There was a question, but I answered it.
Perfect.
It wasn't a real question.
Any other questions? Fastest question session ever.
Awesome. Okay, thanks everybody for coming.